Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 287. Please turn to page 287. Today's our lesson number 190, and the problem that we are about to solve is 136. Let's take a look at it. In 136, we are given this symbol here, and we are told that it represents one of these three operations, either addition, subtraction, or multiplication. The question simply is this equation that is given to us something that holds? Is it true? Let's find out. Let's see what they give us. In the first statement, they tell us, let's see what do they tell us in the first statement. They tell us that k dot 1 does not equal 1 dot k. Now here's what's going on. All we are told is that this dot represents one of these three operations, either addition, subtraction, or multiplication. Therefore, our first job is to actually ascertain which operation it is. Once we know which operation it is, then we can employ that operation and be able to answer this question either in a yes or a no. Let's find out. For example, if had it been addition, if the operation in question had been an addition, it would have been k plus 1. But k plus 1 would have been equal to 1 plus k. K plus 1 would have been equal to 1 plus k. But we are told that it does not equal to. That tells us, this implies that it's not addition. The operation in question is not addition, because had it been addition, this would have held. Similarly, k times 1 equals 1 times k. Both in addition and in multiplication, order doesn't matter. A times b is same as b times a. A plus b is same as b plus a. That also tells us that it is also not multiplication. It's not multiplication. Well, then it's got to be subtraction. It's the only one left. It has to be subtraction. So now that we know that the operation in question is a subtraction, let's do it. Let's find out. Let's answer this question. Let's answer this question here. So the question now is k minus L plus m equal to k minus L? Wherever we see this dot with the circle, we have to replace with the minus sign. K minus m. That's what we want to know. Well, let's find out. And this is going to be k minus L minus k plus, oh, it's plus sign, sorry, it's a plus here, plus k and then minus m. Either way, we have arrived at the same conclusion, but we would have arrived at the same conclusion we would have arrived at the right conclusion for the wrong reason had we put here a negative sign. But anyway, what we end up here is k and a k, so we end up with 2k minus L and an m, so it's L plus m, negative L plus m, and here we have k minus L plus m. The problem here is, here we have 2k, here we only have 1k. This obviously is not equal to, and therefore we have answered the question. The question was, is it true? To which the answer is, no, it's not true. Because we are able to answer the question either in affirmative or negative, a definitive answer, therefore the first statement is sufficient. It did the job what it was supposed to do. It enabled us to answer the question. As I always remind you, if it turns out to be negative, it's alright. We have no emotional attachment to this thing at all. We just have to be able to answer the question either in affirmative or negative. Let's see what they give us in the second statement. In the second statement, they tell us that the circle with the dot represents subtraction. Well, that's very nice of them, isn't it? Circle with the dot represents subtraction. That's exactly what we found here. Except here in the second statement, they just tell you outright They just tell us outright that it's subtraction. Once we know it's subtraction, we'll do the same exact operation that we did just now, and again we'll arrive at the same conclusion that this statement is not true. Therefore, if the first statement was enough by itself, then so would be the second statement, because it tells us the same exact information as the first one did. The only difference is that in the first statement we had to extract this part. We had to work on it. But over here in second statement, they just tell you outright that the symbol represents subtraction. Therefore, second statement is also enough by itself, and hence the answer is B. Let's do the next one, shall we? Let's do the next one. Number 137. Let's see what they have in 137. You will have to excuse me just for 1 second. I'm still here, and I'm not going anywhere at all. Number 137. We are told, rather we are not told anything, we are being asked how many of the 60 cars had neither power windows nor stereo. The question is, how many of them had neither power windows nor stereo rather. Let's see what they tell us. In the first statement they tell us that out of 60 cars that were sold, 20 had stereo but no power window. Does this help us? No. Answer is no. This by itself does not tell us how many had neither. All we know is that 20 had stereo but no power window. There's no way to figure out how many had neither. The first statement by itself is not sufficient. Because the first statement by itself is not sufficient, A, D, B, C, E. Because the first statement by itself we just found out is not sufficient, we know now that the answer cannot be A, nor can it be D. It would have to be either B, C, or E. Let's look at second statement. In the second statement they tell us that out of 60, 30 had both. Again, by itself, this information does not tell us how many had neither. It does not, alas. Therefore the answer cannot be B either. It will have to be either C or E. Once we put the two statements together, and if we get somewhere, then the answer will be C. If we don't get anywhere, if we still hit a dead end, then the answer will be E. Let's put them together, shall we? When we put them together, 1 and 2, we find out. It's always a good idea in questions like this to employ Venn diagram. It makes much easier to visualize everything. So here's our stereo, here's our power window. The first statement tells us that 20 had stereo but no power window. 20 had stereo but no power window. So that comes from statement number 1. Second statement told us that out of 60, 30 had both. Alright, so 30 had both. And that comes from second statement. How many cars altogether were sold? And the answer is 60. Here is the X part, the unknown part, the number of cars that only had power window but not stereo. Now what does it tell us? It tells us, when we put them together, it tells us that there are two possibilities. There are two possible scenarios. One possible scenario is that because there are 60 cars altogether, I did not write anywhere, right here. Because there are 60 cars altogether and this adds up to only 50, this tells us one possibility is that either up to 10, up to a maximum of 10 had power window but not stereo. The highest number that X can take is 10 because it has to add up to 60. In which case, if that is true, if that happens to be the case where 10 cars, the maximum of 10 cars that are here, the highest value that X can take is 10. If all 10 of them, it turns out, had power windows but no stereo, then that would also mean that and none had neither. There was not a single car that was sold which had neither power stereo or power window or a stereo in the first case scenario. Another possibility, scenario number 2, is that up to, so this is the or part, or number 2 scenario, or 10 had neither power window nor stereo. So we're looking at two scenarios. In this scenario X is equal to 10, in this scenario X is equal to 0. In other words, nothing falls here. Nothing falls in a situation, nothing falls in a category where none of the car had only power window. Up to 10 car had neither power window nor stereo, which means there was not a single car that had only power window. And none had just power window. And none had just power window. As we can see here, X is equal to 0. The question is, which one is it? We want to find out how many had neither. How many had neither? It could be up to 10 which had neither, or it could be just 0. There were 0 cars with neither of these features. Well, which one? Or it could be anything in between. Who the hell knows? The answer is E. All that work for naught. Answer is E. I will see you tomorrow. These E problems are very annoying. You do all that work and at the end you get this anticlimax. I don't care for them. I'll see you tomorrow, okay? Bye now.